is true. Matter is anything that has mass and is space. Matter exists into three states. One, this solid, Karo, gas, Kisha, liquid. Karo, trial. Okay, trial fail. Hakuna mtu anakujaji hapa. What is an atom? Actually, an atom is the smallest particle of an element. Smallest particle of an element. That can't be seen by our naked eyes. So these particles, known as the atoms, are further subdivided into subatomic particles, known as, we have one, the protons, two, neutrons, and electrons. So an atom is subdivided into subatomic particles, which are protons, neutrons, and electrons. And then these atoms join together to form molecules. Hapo tumeingia chemistry kidogo. So atoms join together to form. Joyce, nimesema nini?
I'll just repeat kwa mwenye amejoin saizi.
So we are tackling the topic particulate nature of matter, whereby we said that matter is anything that has mass and occupies space. Anything that has mass and occupies space. Matter also does exist in three states, that is solid, liquid, and gas. Then this matter is made up of atoms or many particles, known as the atoms. This atom is subdivided, these atoms are subdivided into subatomic particles known as the protons, neutrons, and electrons. And then these atoms join together to form, Joyce, nimesema? Molecules, exactly. So we have these particles move from one region to the other through a process known as diffusion. Mnakumbuka what is diffusion? Kisha? Diffusion means?
It is the movement of molecules from a region
from a region of
high concentration to a region of low concentration.
Is it high to low or low to high? High to low, exactly. So diffusion is the movement of molecules from a region of high concentration to a region of low concentration. In biology, tungesema through a semi-permeable membrane, kitu kayo. But in physics, tunasemanga so as to attain a state of equilibrium. A state of equilibrium is a state of balance, okay? So diffusion refers to the movement of particles from a region of high concentration to a region of low concentration so as to attain a state of equilibrium, so as to attain balance, whichever suits you. Are we together up to that? Okay. So, tutaangalia these three states of matter individually. We start with solids. How is the concentration of solids? Are the particles packed together or far away from each other? Packed together, right? Okay, this inapatikana when you boil something ama when you heat something that is in a solid form, ni ngumu sana uone change. For example, a ball bearing. You say, I mean, we have a carrying, you can lecture, and then a ball, a metallic ball. Let's say we heat up this ball. Itaweza kupita hapa. When you hit this ball, what happens? It expands, right? Making it difficult to pass through this. No. But when it cools, it is very possible for it to pass through this ring. So change in temperature also affects. Just a minute. Where was I? So when you heat up this ball, it expands, making it difficult to pass through this ring. When it cools, it never pita, okay? So, maybe unaweza pata a question like that. Sana sana zokuja question number 1, number 2, question number 1, number 2. Okay. So solids tumesema they are closely packed together. Utazipata in this form. We have this and then we are like this. Like zimeshikana. Hiyo ndio tunamaanisha. Sawa. Liquids. What are liquids? Ni vitu zina flow, ndio? Kama maji and such, ndio? So for the liquids, tumesema they are closely packed together. For the liquids, they are slightly packed together. So hizi zimeshikana sana. For the liquids, we have this. Kuna kagap kadogo. Unaelewa? Kwa pamoja. And then last but not least, we have gases. Gases are widely spread. They are widely spread. Tasema together, widely spread together. They are. Diffusion mostly occurs in gases, for they are widely spread. Here tumeshika. Okay, my question. State the reason. Andika kwa kitabu. Nitaangalia anza. State the reason why gases. State the reason why gases are easily. State the reason why gases are easily compressible. While liquids and solids are not. That was a question number 6. State the reason why gases are easily compressed while liquids and solids are not. When you're done, unaweza inua mkono. Just maliza. Karo, uko sawa? Maliza utusomee jibu yako. Aya, Joyce, tusomee.
Its particles are widely spread than that of solids and
Which
liquids.
particles? Whose particles?
Gases.
Gases, exactly. Keyword, usaisahau, sawa? Don't assume that I know, okay? Hiyo ni kitu moja inaweza kufail sana. So, gases are widely spread and as compared to those of solids and liquid. Hivyo tu. And you earn your mark. Just that. Question. Another question. Explain the cause of random motion. Explain the cause of random motion of smoke particles as observed in Brownian motion. Explain the cause of random motion of smoke particles as observed in Brownian motion. I'm very sure I'm come across that experiment in Brownian motion. So explain the cause of random motion of smoke particles in Brownian motion. Kumaliza, raise your hand. Nataka kuona venye una explain. How do you explain? Kero, unajua Brownian motion ni nini? Umesoma hiyo? Haiko form 1? Give it a try. Kisha umaliza. If you take whatever we have learned here, we apply hapo, I'm very sure utapata answer. Mostly applying to gases. And then we move on to pressure sasa, our main topic of today. whatever we have learned here kwa hiyo. Let me give you a clue. These gas particles, they are ever moving, haziwezi simama. So take an example whereby pressure inaapplywa, hizo particles zitakuwa zina move aje? Vigorously, ndio? Sasa you have a clue now. Okay, let me read the answer. Smoke particles are continually bombarded by invisible particles of air that are in a constant random motion. Smoke particles are continually bombarded by invisible particles of air that are in constant random motion. Obviously, the atoms, the electrons, the whatever, the molecules, they are ever moving. So when those smoke particles come into contact with them, they will also gain that momentum. So, yeah. So tuingie kwa pressure. What is pressure? Define pressure. Define pressure. What is pressure? Pressure is defined as the force per unit area. That is mathematically defined as the force per unit area. What do I mean? Pressure is defined as the force per unit area. That is the formula of pressure. So, what is the SI unit of pressure?
Newton per meter square.
Newton per meter square, which is also not referred to as Pascal. Also known as Pascal. So with that formula, see, I can give you a question we tried. Sindio? Pressure inanga mambo mob. Okay. Write this down. Okay, before that, let me read something. The pressure in solid depends on the surface area of contact. A force applied by a small area exerts high pressure as compared to when it's applied by a large surface. What do I mean? That is why feet of an elephant cannot sink into the soft soil, even just a minute. Even if the elephant is very heavy due to a large surface area over the elephant feet. Okay, hiyo grammar yao haiko poa. What do I mean? As in solids, let's say for example, someone nimevaa high heels. I exert a lot of pressure to a point that nikikanyaga pale nje I'll make holes, right? But let's say nimevaa hizi viatu, sita make holes, no? So the pressure exerted kwa hizo heels ni more than rubber shoes. So another instance ni a sharp edge of a knife cuts easily than a blunt knife because a sharp knife has a small surface area. Okay, let's say an example. A block of wood that weighs 30 newtons measures 5 meters by 10 meters. In an example, I'll give you the equation. So a block of wood that weighs 30 newtons and measures 50 meters by 10 meters by 4 meters. If it is placed on a table with the largest possible area of 5 meters multiplied by 10 meters, in contact with the table exerts less pressure than blah blah blah. Wamepeana nini mingi. Just a minute. Nimepata example nilikuwa nataka. Mnaweza andika hii. A tip of a needle has a cross-sectional area. A tip of a needle has a cross-sectional area of 1 multiplied by 10 to the power of 6 meters squared. 1 multiplied by 10 to the power of 6 meters. That's what the tip of the needle. What is the pressure exerted at hiyo ni direct, a very direct one. I'll give you a hint. Pressure is equal to force over area. We have the area already. This is our area. We also have our force, which are given 2 newtons. So calculate the pressure. I'm going to use that. Finished. Okay. Mwingine before I mark this one. The force nimewapea as 2. Nimewapea newtons kama nini? 2. Okay. Nimeona kwenye wamekosea. Joyce, is it really a negative? Sure.
Juu hii kuna hii ikiweka yani bila sana form itakuwa na 0.6 na kwa sasa itakuwa na decimal itakuwa 0.00
0.00. Actually ni 5. Why mbona umeweka 6?
ni 6.
Sure. Calculator kwa nini?
Juu
Tabu to the same and whatever. Wanzie tena. Job na wamepeana a very different answer of which naishuku
1 times 10 power 6 inakupea 1 million. Then 2 divided by answer 2 times 10 power -6.
Karo umemaliza? You done? Umeelewa venye nafanya? Okay. Nice. Ila kwanza hizo zingine sijamwa. Umeelewa venye nafanya? So you just come and substitute whatever you're given. Already hii ndio data yetu. So we know that pressure is equals to force over area, right? So pressure is equals to, what is our force? 2 all over this one, okay? Hii power inamaanisha, this is 10, haimaanisha ati ni 10 times 6. Mnajua kwa nini? Karu, mnajua kwa nini? Hujafika hapo. Na si mmefanya pressure? Mlikuwa kwa nini? Okay. In short, hii ni a million, okay? Okay, this 6 will represent the number of zeros in layman's language, sawa? So this is a million. Sawa? So unakuja unaiweka over a million hapa. Ama simply hivyo unaweka brackets into the calculator. Usiwe work bila the brackets, sawa? Especially when you divide with something, sawa? Okay, let's move on. So the answer inafaa kuwa 2 multiplied 2 by 10 power -6. Unaweza weka 2.0 ama 2 just 2. Sawa? State the reason. State the reason. State the reason why it may not be. Why it may not be possible. Why it may not be possible to suck liquid. State the reason why it may not be possible to suck liquid into your mouth. Using a drinking straw. On the surface of the moon. On the surface of the moon. Just try. It's very simple. Very simple. So in short, the answer is there is no air pressure on the surface of the moon that can act on the liquid. There's no air pressure on the surface of the moon that acts on liquids. Pretty simple. Tufanye model calculation. Okay, in your calculation, the total weight of a car with passengers, is 25,000 newtons. Total weight is 25,000 newtons. full stop, the area of contact, the area of contact of each tire, the area of contact of each of the four tires, of each of the four tires with the ground, the area of contact of each of the four tires with the ground is 0.025 meters squared. 0.025 meters squared. 0.025, okay? Meters squared. Full stop. Determine the minimum car tire pressure. Determine the minimum car tire pressure. That was a two question number 5 for one. Try. Una collect data, what you're given first. How does this formula apply? Same as supata correct. Just try. Pretty simple here. Yes. Pretty simple. Ukimaliza nipatie. Funny. Okay. Pass on the bottom. How many tires are there? Pagari kuna mwanga na kumbate. Kama hii ni ya moja. How about this? Multiply by 5 then. Iko sawa? By the way. So this is the answer. With this formula, pressure hatujui. What is our force? 25? Tumepata 25,000. 25,000 newtons. What about our area? Tumeambiwa the area of contact of each of the four tires with the ground is 0.025. So 0.025 multiplied by the four tires. So hii lazima uko practical. Sawa? So what do you get after hiyo? Unapata nini?
250,000.
250,000 what?
Newton per meter square.
Pascal sama newtons per meter square. Meshika? If you have a question, kindly ask before I move on to the next thing. Answers hapa naona ziko wrong. Mambo yanaonekana ni 25,000. They missed Tanzania. Up to there, any question? Any question? Okay, fine. Still on the same question, yenye umeandika. Let's change it up a bit. Hapo penye umeambiwa the total weight of the passengers is 25,000 newtons. Change that to just wait. Let me find another question. Suppose tulikuwa tumepewa let's say we have the pressure which is this na hatujapewa this one. How do we find force if we have pressure and area? Karo? What if tumepewa the pressure which is this and tumepata hatujapewa this force, so we hakuna. How do we find this force if we have pressure and area?
Na hiyo pressure umepewa, then na hiyo chini.
So the formula will still be the same. In the formula, we are not given this force, but we have this and we have this. So what we do, we una cross multiply. So we say our force is equals to, if force ndio tunatafuta, hii equation itakuwaje? Tutakuwa na pressure multiplied by the area, okay? So una play along with them, multiplied by the area. What if hatukuwa na area? The same formula itakuwa, we have this and this, we don't have this. So our area itakuwa nini?
Pressure.
Force over pressure, exactly. Meshika? Unacheza tu na formula yenyewe, sawa? As long as you know the formula, you're good. Sorry?
Like a triangle. That triangle.
Yeah. Yeah, exactly. So you just play along with them, sawa? Sitaki kuexpand sana isiende tena nini. Kuna ingine, there is a more complex one. Sijui niko form 3. Ni form 3. Pressure bado utaipata bado form. Hydraulic, exactly. Lakini sasa nikifunza ndakuwa na confuse. Kwa form 1. Mmesoma pressure? Mmesoma pressure?
Topic 4.
Topic 4. Mbona unaona nika form 2? Nimefanya hivyo sana. Okay, sawa kama hii, write this. A whole of area, a whole of area 2.0 centimeters, a whole of area 2.0 centimeters squared. At the bottom of the tank, 2.0 meters deep is closed with a cork. at the bottom of the tank, 2.0 meters deep, is closed with a cork. Sorry, 2.0 meters. 2.0 meters deep is closed with a cork. Determine the force on the cork. Determine the force on the cork when the tank is filled with water. Determine the force on the cork when the tank is filled with water. Determine the force on the cork when the tank is filled with water. Take density of water to be 1,000 kilograms per meter squared, per meter cubed. Take density of water, hiyo tunaekanga into brackets. Density of water is 1,000 kilograms per meter cubed, and acceleration due to gravity is 10 meters per second squared. And acceleration due to gravity is 10 meters per second squared. I repeat, density of water is 1,000 kg, 1,000 kg per meters cubed. Density 1,000 kilogram per meters cubed, and then kuna formulas mbili unaweza tumia. Ya kwanza ni hii yenye nimeandika, this is pressure is equals to height times density. Density na representiwa na hii kitu kama hii, this is not a P, inaitangwa sorry, exactly, and then times the gravitational ama acceleration due to gravity, ama gravitational force. Unaweza tumia hiyo ama utumie